Hi, this is Dr. Kraus, and I'm recording a couple of short videos to promote my summer class, ME 492, ECE 492, ME 592, which is going to be offered summer 2016. It's called Integrated Mechatronic Systems using Raspberry Pi, and in this video I want to answer three short questions. One, what is a Raspberry Pi? Two, what is the difference between a Raspberry Pi and an Arduino, and then how is a Raspberry Pi different from just a regular Linux laptop or desktop. I have here a Raspberry Pi 2 Model B, an Arduino Uno, and a US quarter, just for kind of size comparison, and so you can kind of see the size that we're talking about. The Raspberry Pi fits in the palm of my hand. It's referred to as a credit card size computer. It is comparable both in size and cost to the Arduino Uno. The Arduino will run $25–30 depending on where you get it and whether or not you buy an imitation one or the authentic one from Italy. And the Raspberry Pi 2 by itself is $40, but it needs a micro SD card and a USB Wi-Fi dongle, which is both about $10 for it to be truly useful, in my opinion. It also has 4 USB ports, a wired Ethernet port, a HDMI cable, full-size output, and it's powered by a micro USB cable. It also has 40 what they call GPIO pins, global pin input-output, and so you can use those to read sensors or send actuator signals or connect them to other devices via I2C or SPI or whatever. And there's also a connector here for a little camera module. That's another $25 that comes with it. Yeah, it's a powerful little device. It's a full-size computer. Let me show you. So this is the desktop of my Raspberry, not this one, but another one that I have running right now. And so you have a legitimate desktop environment. There's kind of like a start menu with some different programs that are running. I've got a browser open to Google News. I can open up a terminal and do, normal Linux terminal things. So I'm going to open up Python, and I can generate a vector and make a plot of some data like so. And so it's essentially almost like a tiny MATLAB-like environment using the Python and the scientific routines for linear algebra and stuff. And so that's there. I also have a code editor if I needed to edit some Python code or whatever. And so it's a legitimate computer with its own desktop environment. Yeah, let's talk about some specs really fast. Okay, so it's a $40 computer, useful for physical computing and Internet of Things applications, connecting it to sensors and actuators. It has a quad-core 32-bit 900 megahertz processor, 1 gigabyte of RAM, and then the micro SD card is essentially the hard drive, and so that can be 16 to 32 gigabytes. So if you compare those numbers to an Arduino RAM is measured in kilobytes. It's a single-core 8-bit microcontroller. I mean, the Arduino is a really cool device for what it does. It's a really user-friendly microcontroller, but it doesn't really have an operating system. The only real way to interact with an Arduino is through the serial port or to hook it up to I2C or SPI or whatever. There's no such thing as a desktop. There is no operating system. Now, that can be an advantage in that the Uno can easily do real-time stuff really fast, where that's really hard to do on a Raspberry Pi. The Uno has onboard analog-to-digital conversion and PWM outputs and those kind of things. The Raspberry Pi can sort of do PWM, but analog-to-digital conversion on board, it can do really fast things, and those are things that the Raspberry Pi can't match. But the Raspberry Pi provides Python instead of C, and Python is a lot easier to program than C. It provides, gigabytes of hard drive space if you need to log data, and it can connect to a normal Wi-Fi connection. I've seen lots of Wi-Fi shields and Bluetooth shields and things for the Arduino, but I haven't seen one that I really trust to work reliably. Whereas, for example, this is a VNC connection over my home Wi-Fi network to a Raspberry Pi that's currently running in my house. So I think that's pretty cool. So there are some advantages to both devices. Like I said, Arduino better for real-time and sensor reading and that kind of thing. Arduino much more computational power. One of the things I like to do in my own work is to combine them and connect them together over USB serial or SPI or I2C, and then let the Arduino do the real-time stuff and read the sensor signals and so on, and let the Raspberry Pi do high-level stuff. And I'll create another video that shows me using those two devices together. So the other question you might have is, so what? It's a tiny Linux computer. Why not just use a real Linux computer? And I think there's a couple of answers to that question. One is that it does have the GPIO pins that allow it to directly control, turning devices on or off or reading sensor signals or whatever. And those are things that are just difficult to do with a laptop. Also, if you wanted to, put these around your house for home security and monitoring, or put them in your lawnmower to make it a smart lawn, whatever, it would be hard to just stick your laptop in all of those places, and also potentially dangerous. And so it's cheap, it's small, and it can do physical computing and connect to various signals. So I'm really excited about this device, and I would love to have you join me in my class this summer. And definitely feel free to email me if you've got more questions. Thanks.